Yeah, in the meantime, guys, if you have any queries related to last session, let me know, please.
Hello.
Yes.
Hi. Actually, I just want to know, let's say if I have created in my local, okay, in C drive in my user where I initialize the directory. So
Mhm.
now I created the new directory. Now, I add some files and commit them. Now I want to push them to GitHub. At a time, I got some errors like, let me show you just a
No,
moment.
no, no, just let me know what is there.
I don't remember exactly. Can I share my screen and show you?
No, this topic is not yet, discussed. Okay, today we are going to discuss about that.
Okay.
What we are doing is we are dealing with the local machine, local repositories, correct?
Yes. Mm-hmm.
So today I'll show you how we can able to clone the repositories from the remote environment and also how we can push it to the remote environment.
Oh, okay. All right.
To be clarified.
Fine. Actually, I was not able to attend the last session on Sunday. That's why. So I just went through the recordings and
Oh, okay.
checked that. Yeah. Okay. Thank you.
Yeah, sure. It'll be discussed today, so don't worry. Hmm?
Sir, can we also get this notepad link once again because I was not able to join like last classes?
Okay, okay, sure, we'll do that. I'll be sharing the link as well. I hope you have access to GitHub, right?
No, sorry. If you just share the link, I'll join.
Okay, fine. Just a quick summary of what we discussed on last session. So last session, we started with the version control system using Git, that is on Sunday. And we discussed about the miscellaneous Git commands that helps to create your local repositories, work on the local repositories, how to add the changes to staging area, and from staging area, how to commit to local repositories, all the stuff. And also some of the commands related to the logs, difference, show command, removing the entries from staging area. And also we discussed about git ignore file for ignoring the file patterns, as well as we discussed about the revert activities, like how to undo the changes using reset as well as revert. And then we start with the branching. And in branching, we discussed about the branching strategies. Okay, various strategies, how we usually define the strategy to ensure the integrity of a master branch. Because basically your Git is a distributed version control system, which allows a parallel development, right? So in order to enable the parallel development, we are going to use a branch-based working, working process. So whenever we create any file or any repository, it will be based upon your default master branch. So this default master branch is considered as the master copy or a production version of your source code. Like for example, when you're working on your local repository or even your remote repository, if you want to share your content to others, you'll be sharing it through master branch only. You might be working on your own feature branches, but you're not supposed to share the feature branch changes because feature branch changes are not a completely tested version. Correct. So that is the reason master branch should be given a more important priority. And at any point of time, the integrity of master branch should be maintained at the max. So how we can able to ensure the integrity of master branch means by introducing some branching strategies. Like I have discussed about various scenarios, right? Considering a independent developer with a single feature and considering a independent developer with multiple features and considering a team as a team with more than one developers. And similarly, when a team size grows, if more than one team members want to access the same repository, how to ensure that integrity. So on that perspective, we discussed about various strategies, right? So in today's session, we'll continue with this module, Git module, where I'll be showing you how we can able to work on Git branches and how we can able to, take care of the integrity of the master branches in any repository. So today is day 3. 10th. Today is, sorry, 7th, right?
7th.
Thank God. 7th October, right? Okay. All right. All right. So what we'll do here, we'll just focus on Git branching. And then we'll see how to work on the branches, how to create the branches and all those stuff. So if you're talking about the repositories, right, we'll be using Git in a local machine. Like once you install Git in your local machine, you'll be getting your Git bash. So let me start Git bash. In E drive, we have that folder, right? I believe like. It's something called as DevOps. So this is the folder we have created. This is my root directory where I want to maintain a number of project folders. Right? Guys, am I audible to everyone?
Yes.
Yes.
Okay, thank you. So let's create a new repository for today. Okay, let me start from the scratch. So from this root, I just want to create one directory, and it will be like test repo1, and get into that repository. And here I just want to create a new Git repository. So what's the command to initialize the repository here? Will be
Git init.
Git init command to initialize the repository. This will create a new directory called .git directory, and within that, Git maintains all the metadata in order to maintain your Git repository. Also, it creates a master branch. And now if we say Git status, we have nothing to commit because there is no files created at this point of time. So now let me create some files. I'm going to make some commits in the master branch. File or s1.txt. And once a file is created, what is the command to add to staging area? It is git add dot. So this will add all the changes from your working directory into staging area. And if you want to commit, you can simply say git commit -m followed by the commit message. Like I can name it as, tag it as CM1, commit message 1. And similarly, let's consider we are making some more changes here. This is my commit 2, and this is commit 3. So if you see here, we have 3 files created here. And also if you can notice, git log, I can able to see there are 3 commits. So let's consider the workload of a development or developers. So consider we have a source code repository with a master branch with some existing application code. So let's take this scenario. So if you work on this scenario, based upon this, you can able to implement all the other scenarios as well. So now that we have created a repository with a few commits, CM1 to CM3, there are 3 commits we have created here. And now I want to do some parallel development. I just want to do some enhancement in the project, or it might be adding a new source code file, or it can be updating existing file. It can be anything. So whenever I want to make any changes, the developers are not supposed to directly work on the master branch, because master branch is considered a production version. We are not supposed to directly update the master branch. So what we do here means we'll be trying to create a feature branch here. So to create a branch, there are various commands available. like so the very first command, you can simply select git switch -c followed by the branch name. Or you can use git branch followed by the branch name. Or you can say like git branch or git checkout -b followed by the branch name. Like this, there are various options available. It's all now introduced over the period of time. Okay, as part of the evolution of the Git versions, right? They introduce new features. So initially, when Git was introduced, we were using just this command to create a branch. Then they introduced checkout. Now the latest versions of Git supports git switch command. So you can able to use anything as per your requirement because it's just going to do the same activity. So in general, if you simply say git branch, this command is going to get the list of branches. So as of now, in this repository, I have only one branch called master, and this master branch is considered the default branch. So this asterisk denotes the current branch where we are now. Correct. And if you want to create a new branch, it's very simple. Simply say git switch -c. -c is used to create a new branch and give a branch name like feature 1. So now the function of this switch command is to create a new branch, and the control will be switched to the branch here. See, initially it was in master branch. Now the control is switched to feature branch. So branches are nothing but the replicas of your base branch. So if I say ls, I should be able to see the same files. What are all the files we have created in the master, you can able to access from feature. And also if you say git log, you can able to see the commits. What are the commits we made in master branch? Just reflecting here. So at this point of time, we have feature 1 and master, both are in sync. Correct? Because we just created what are things you have in master, it just copied into the feature. That's all. Copying means it is not a physical copy, it's a logical copy. Always keep that in mind. Whenever you create any new branch, the new branch is the logical copy of the source branch. Clear? It is not going to allocate a separate memory or space for that. Just a logical entity. Only the incremental changes will get added here. Any question? And now if I say git branch command, you should be able to see we have 2 branches and currently we are in feature 1. Okay, so please don't try anything there. Just listen what I'm doing and try to understand. If you are having any question, just let me know. And let me go. If I want to switch back to master, I can simply say git switch master. So without giving -c, if you specify the master branch name of a branch, the control will be moved back to the branch. See, now we are in master branch. So this is how, using a simple switch command, we can able to create a new branch as well as we can able to switch to any other branch. Same thing is used by checkout also. We have something called git checkout -b followed by the branch name feature 2. See, this checkout command also creates a branch and it will just get back to your new branch. And if you want, you can go back to that branch again. And similarly, if I say git branch followed by the branch name, it creates a branch. So the git branch followed by the branch name, it will just create a branch based upon this master, but the control will still remain in master branch. It won't switch to that new branch. So like that, you can able to create any number of branches like this. And if you say git branch, you can able to say the control is still with master. So without switching to any other branch, if you simply want to create the branches, means you can use git branch followed by the branch name. Simple. So understood, right? How to create the branches here? So very frequently in real-time environment, we'll be using these two commands, git switch and branch commands. So if you look into this git log, now you can see what are the branches we have created. For all these new branches, master is a base branch. And at this point of time, the master branch and all the feature branches are in sync with 3 commits. Hope you're following this. Fine. So now, if you want to work on this, let's say I just created some features here and I just want to work on the feature. So if you want, you can give git switch feature 1. I want to get into this feature and let me say git log 1 line and ls. So it is in sync with my master branch. Now here also I can able to do some changes. I can make some incremental changes here, like echo record 1 q1 dot text. Similarly, I can add these changes to my feature branch staging area, and then I can commit this, commit -m cm1 from feature 1. This is commit from feature branch 1. And if you want, you can able to add a few more changes. Commit 2. So now if you say git log, what you can observe here, your current branch, the feature branch, is 2 steps ahead of your master branch. Correct? Can you able to see the difference now?
So we can't see that changes in the master, right?
Yeah, at this point of time, we have updated in feature branch.
Okay.
And your feature branch is 2 steps ahead of your master branch.
Yeah.
The files like Q1 and Q2 are created in feature 1. So if you quickly switch to master, and if you say ls, you won't find the changes there. And if I say git log 1 line, your master branch is not yet updated with the feature. So this is what we call it as a parallel development without impacting others' changes. If you want to work on your current release or current changes independently, we'll be using the branches. Like that, if I want to work on 5 different features, I can able to create 5 different branches and I can work on my changes independently. Upon creating these changes, I can able to test the changes independently. And once I'm ready with the changes, if I want to share it with other users, I can merge my changes to master branch. Easy. So point here is, after creating a branch, make some incremental changes in feature branches. Got it. Understood the statement? So in order to merge the changes to target branch, first you need to switch to target branch. And then you'll be issuing a command, git merge command. means you'll be issuing git switch master, and then you'll be issuing git merge feature 1. So this is what we will do now. It means my changes are ready in my feature 1. Once the changes are ready in feature 1, you should issue a command git switch to the target branch. And from the target branch, you can issue git merge followed by the branch name, like git merge feature 1. So this command will merge the changes from feature 1 into the master branch. And now if you say git log 1 line, you can able to see what are changes you made in feature, it is merged with master. So at this point, your master branch and feature branch 1 is in sync. And if I say ls to get the file list, I can able to see in master branch, I can able to see the changes from feature. Easy. So always keep one thing in mind, whenever you want to merge changes, you need to first switch to the target branch, and from target branch, you should give a command git merge followed by the branch name. So why I'm mentioning like a current branch and target branch means this current branch and target branch, it can be anything. Maybe in this example, you can consider like current branch as a feature and target branch as master. But if you're considering the workflow, entire branching strategy, let's say, for example, if you're talking about scenario 4, in scenario 4, if I'm working on this particular feature 2 branch, so for this feature 2 branch, which is the target, guys, last week we discussed about the strategies, right? So
Developer branch 2.
So for this, the target is developer branch 2. Correct. Similarly, for this developer branch 2, which is the target?
Integration branch 2.
Integration branch.
Integration branch of team 2. And for this integration branch, the
And
release branch is the
release
target,
branch.
and for
Release
the release
branch.
branch, the target is master. So that is what the hierarchy. So whenever we are following the branching strategy, we never allow the feature branch to directly interact with the master. We are not supposed to directly merge things from feature to master. So that is how we just follow the strategies. Strategy means it's a process. It is not like a tool to strictly validate and all. It is a process. So everyone who is involved in the process should understand their responsibility while working on it. And during the application architecture, this strategy will be decided, like how many repositories they want to maintain, what are the files and shared components they want to maintain. Everything will be decided by your application architects. So any question here? So now you should know how to create a branch and how to work on the branches independently. And once things are ready, you should know how to merge it to the target branch. Easy. Like this, you can able to consider any changes. Like for example, in the meantime, any other developers can able to work on their changes. Like git switch to feature 2. So this feature 2 also can able to make some changes. Let's say he can able to make a quick change. And he can able to add changes to its local staging area, and then git commit -m. This is CM1 from feature 2. It's done. So if you think this changes is okay, now you can see the feature 2 changes are one step ahead of your feature 5, 4, and 3. It is not having any reference of master or feature 1. Why? Because already master branch feature 1 are in sync. So now if you want to merge this to master, what you should do?
Check out to master and
About
then
master and
So just
merge that.
git merge. Feature.
switch to master first, and then issue git merge feature 2. Oh, sorry. I think I missed the merge activity there, right? So no problem. So now you can able to see it has merged the changes. So now if I say ls, I can able to see the files whatever we have created. And if I say git log one line, I should able to see we are just merge the changes. Latest changes are merged into this one. So point here is at any point of time, independently, we can able to work on the changes. All developers are allowed to create their own branches, feature branches. Whenever developers working on a release, they can able to create their own feature branches and start working on it. It's not an issue. But the point here is how to handle the shared file and or handle merge conflicts. So merge conflict is one of the important scenario. So let's say, for example, consider I have a master branch, and in this master branch, assume that I create a file. And in this file, I have two records. Correct. This is the only file I have in master branch. Now, if I create a feature branch out of it, so now the feature branch also will be having the same content, right? When we create. Do you agree with that?
Yeah.
So when we create a feature branch, this feature branch also will be having the same content. And now I want to make some incremental changes. Okay. And assume that we have another branch called feature 2 also here in this place. So now both feature 1 and feature 2 wants to work on the same file and update the changes. So in feature 2, I'm just making some changes here. And similarly in feature, so I'm just making changes. So now both the features are ready with the changes. When feature 1 try to merge it to master branch, it won't create any trouble because it's the first time we are updating it. So these updates will be accommodated here. Correct? From feature 1, if you merge, the later change will be updated in master branch. Now, when feature 2 also wants to merge into master branch, in that case, it will create a conflict. Why? Because already the master branch update with feature 1 changes are the same file and the same record. Now, feature 2 also wants to accommodate change, means how it is going to handle this conflict. How we can accommodate more than one value in the same record. It's not possible, right? Hope you can understand scenario now. When more than one user or more than one feature are trying to work on the same file at the same record level, then comes your merge conflict. So in order to handle the merge conflict, you need to follow certain scenarios. First, let's create the conflict, then I'll show you how to fix that issue. So let's create a folder here. And let me get into the folder and initialize it. So let's create some commits here, like throw. So now let me create a new branch. Git branch followed by the branch name feature 1. And also I'll create one more branch called feature 2. So now you can see both the branches feature 1 and feature 2 are in sync with master with only one commits. So this is what the changes we had in master. Now let me switch to feature 1. And I'll be creating some changes here because I have only one file. I want to make some changes. So if I check the file content, I have only one record. Let me add a new record here. From feature 2, just for a reference. You want the text. Hope you all can follow right what I'm doing here, or any confusion. Guys, is everyone able to understand what I'm doing here?
Yes.
Yes.
It should be feature 1, right? That record 2 from feature 1.
Yeah, it's just a record value, right? If you want, you can update it, no problem.
Yeah.
So that's not an issue. So what I can do, I can simply say like vi followed by that file name q1, and let me update this record 2 from feature 1 and save this file. That's it. So now if I say cat q1, is that fine, right? So now I just made some changes in the file. Let me add it to staging area, and let me commit it to -m. This is CM1 from feature 1 for our reference. That's it. Now if I say git status, it's clean, and the log should say your feature branch is 1 commit ahead of your master branch. Correct? Is 1 commit ahead of your master branch. It is not in sync now. So now let me go ahead and update my master branch. So git switch to master, git switch to master, and then say git merge feature 1. So now it is merged into the master branch. And if I say q1.text in master, I should be able to see the record. Now assume that in the meantime, while you're working with feature 1, in the meantime, the feature branch 2. So here also you can see the same file, like cat q1. You can able to see the same file. And if you want to make some changes here, like go record 2 from feature 2. That is q1.text. And this guy also updated the changes in his local repository. -m CM1 from feature 2. Correct. So feature 2, it is independently working on changes. And if I say git log 1 line, your feature 2 is updated with the master. But now the point is your feature 2 is not having any clue about what happened in the master branch. If you can see here, it is having only one file with its own record. So now in this case, if I want to merge this to master branch, I can switch to master first, and I can simply select git merge followed by the branch name. So what will happen now? So this is where the scenario which is going to cause merge conflict. See? Conflict occurred. Merge conflict in q1.text, and automatic merge failed, fix conflicts, and then commit the result. This is what status. And it means the merge failed. The status, if you can see, it is still in merging state. It is still in progress. Your working tree is not clean. If you say git status, you can able to see some changes, some conflict is happening here. Your master branch is getting corrupted because of this commits. So it is our responsibility to fix the issue now. So how to fix this issue? Conflict. So this is what a very important scenario to consider. So as far as Git is concerned, Git can able to identify the merge conflict. In which file the merge conflict occurs, it will try to identify it. But it is not having any intelligence to automatically fix the merge conflict. So merge conflict should be fixed only by the developers or who is the owner of that repository. Only they can able to fix it manually. There is no other option. So in order to fix the merge conflict, you need to follow certain steps. Guys, it's a very important question also. Please pay attention. So first thing is you need to identify the file or files causing merge conflict. This is the first point. Second point is review. Changes happened in that file and decide and then finally you can able to add and commit the changes in target branch. Okay, so here also I'm not specific to any branch here. I never call it as a master branch. It can be a target branch at any point of time. So first thing is you need to identify the file which is causing the merge conflict. That's the first thing you should consider. And review the changes happen on the file. What are changes happen on the file? You have to review it manually. And then decide which changes has to be retained in the target branch. And once you decide that, update the file accordingly. And remove all the unwanted header and footer messages created during the merge conflict. And then add the changes and commit change to the target branch. So in this case, if we see here, how to identify, the very first point is to identify the files that is causing merge conflict. So for this, you need to worry. Git itself having the intelligence to identify the file. See, when merge conflict occurs, you can see there, right? Merge conflict in q1.txt. So it is automatically giving the file name. If there are some conflicts in more than one files, you can able to get the list of all the files causing the issue. Or by using the status command also, you can able to identify the file which was updated recently. Got it? Like this, we can able to figure out the file name. Once you get the file name, you have to review the content. So now let me get into this file, vi q1.txt in master branch. Go to insert mode and just review the changes. So now you can see the initial record is REC1. It was not creating any issue, but the records like record 2 from feature 1, which was already in master branch, because of that, and latest changes from feature 2 is creating conflict. So now we have to decide whether you want to retain feature 1 or feature 2 changes. And then you need to remove this header and footer, whatever created at part of this. So if you want to retain the feature branch 1 means, feature branch 1 changes, you can keep it there as it is. Or if you want to maintain both their changes like this, it's fine, means you can able to keep it as it is, no problem. So remove the header and footer and decide whose records has to be maintained. If you want to have both the things, just have it. Or if you want to have only the feature 2 change, just have it like this. Once changes are ready, save the file and say git add. Still we are in merging phase, okay? And say git commit -m. You can give some messages like resolved merge conflict. So now you can see the merge is completed and the status showing merge now. So now it is updated the branches. Let me get the status now. It should be clean. And if I say git log, you can able to see a new master branch has been created. I mean, new commit has been created in master branch. It's both record. So this is how you'll be handling the merge conflicts. So first you should know why the merge conflict occurs. And once merge conflict occurs, how to fix the merge conflict. Any question?
So after editing, in VI editor, after making the changes, we don't need to execute that command, right? We are in the master branch and we execute that command git merge feature 2.
No.
We don't know. Okay.
See, already you started to merge. It was in merging phase only.
Yeah, it was in merging. Okay. So
Right.
directly we just need to commit. Yeah.
You need to add and commit.
Okay.
After making changes, you have to add
And commit.
That's what. So I just given in the pointer here. Able to refer it.
Okay. All right.
For it. So, but this is not a big deal, okay? Like fixing the merge conflicts and all, it's not a big deal. So whenever we are trying to use DevOps strategy, if you are working in DevOps environment, first of all, you should not get merge conflict. Okay. So we should first of all try to avoid the merge conflict or prevent the merge conflict. Being in DevOps era, still if you are getting a merge conflict and if you are trying to fix a merge conflict, means then you are not in a proper DevOps workflow. Your DevOps strategy, whatever you used, it is totally waste of usage. Correct. We are not in agile methodology. In agile or waterfall model, you might get such issues. But when you're working in DevOps, we should never get merge conflict. That is how you should work. So instead of fixing the issue, you should smartly prevent merge conflict. So how to prevent the merge conflicts? How to prevent the merge conflict?
Before we come merging, we have to merge with the master branch, which is going to merge.
How to prevent? I'm talking about the prevention measures here.
Then we can't implement 2 feature at a time, I think.
Then how can you say it is a parallel development and how we can able to?
Yeah.
There should some locking on that file.
Okay. So it means you're just holding the process for some time, correct?
Yes, yes.
In the time, no other user can able to access it. Like for example, till you complete your merge activity, no one can able to handle that branch, master branch chain, right?
Yes, exactly.
Then that's also not a parallel development, right? We can't achieve it there also, right? Other user have to wait till the user completes their merging.
Okay.
So how to prevent merge conflict? This is where your DevOps intelligence comes into picture, the way you implement DevOps. So, okay, just tell me how you fix the issue. What is the key pointer here to fix the issue? What is the key activity you performed in fixing the issue? Out of 5, which is considered a key activity?
Review the changes happen in the file.
Yes, so this is what it is. So you will be reviewing the changes. What are changes we made in the repository that has to be reviewed? And based upon that review only, we're going to decide whose change has to be maintained. So this you should do before you start your merge activity. Okay, on process level, only with proper review, you can able to prevent the merge conflict. That is what DevOps also says, right? DevOps is all about a strategy which helps to promote the collaboration between the teams. It is not between the teams like development team and operation teams. Even within a development teams, how many developers there are, every developer should know what others are doing. Without proper knowledge, if I simply merge changes, then only the conflict occurs. Before I merge changes, I should know what my peer member is doing. And I should know which feature I'm going to use. And because of the changes, whether it create a conflict or not, I should have that knowledge. I should be aware of that actually. So we are not supposed to work on silos. Okay. When now we're talking about the DevOps, the collaboration between the teams are very, very important thing. If you're not having that, then you can't consider it as a DevOps practice. Can you able to understand what I am saying here? So collaboration is the only thing that can able to prevent the issues. So we might be expert in handling these things. Of course, we are technical people. We should know how to fix the issue. It is our responsibility of the day. But how smartly you are preventing the issue, that is where you can able to maintain the consistency of your work. So preventing the merge conflict is a very, very important thing. During interview also, you might get this question. Got it. What are the best practices you follow in branching while working on Git branches? Means instead of fixing the issue, we will try to prevent the issue by implementing some strategies, branching strategies. Like that, you can able to project yourself in order to work on the report. This is what actually expected during interview. They never ask you, being in DevOps, they will not ask you how to fix it. Because anyway, end of the day, you should fix it. Whether you know or not, you should fix it. But only the leaders, they know how smartly they can able to prevent the issue. So you should be at that level. Am I clear with this point? Okay. So apart from this, we have something called Git rebase and Git squash. So these are the two different options or commands that are associated to merge. So this Git rebase and squash is something considered as the options while merging. And it is just to maintain the integrity of your target branch. Okay, like for example, at any point of time, if merge conflict occurs, okay, there is no problem. Okay, I can't completely prevent the merge conflict. Even after various levels of reviews, if merge conflict is occurred, let it occur, but it should not impact my master branch. That's what the ultimate thing. Even if merge conflict occurs, it should not occur on my master branch, as like how it happened in the master branch here. So what we can do means we can able to use a concept called rebase. So Git rebase, it is used to keep the current branch in sync with target branch. Okay, and it is used to prevent merge conflict in target branch. Okay, it's used to prevent the merge conflicts in target branch. This is what the main point. So how it is going to happen means, whenever we are trying to work in the current branch, if you're ready with the changes, just before the merge, you can issue rebase. So let's say, for example, consider you're working in master branch. Listen carefully, all of you. It's a very important point. Consider you have a master branch with 3 commits, like CM1, 2, and 3. And based upon this, if you create a feature branch 1. So what are the commits you can see in feature branch 1?
Same 3 commits.
Same 3 commits. Similarly, feature 2 also will be having the same 3 commits, correct? Because we have created both the things at the same level. Now, assume that I'm working on feature 1. So in feature 1, I'm making some incremental changes like feature 1, CM1, feature 1, CM2. Like this, I am making some incremental changes in feature 1. And once I'm done with my changes, what I can do means I can simply say git. What is the method to merge a change to master? Normally what we do, we just give git switch to master, and then we'll be issuing git merge feature 1, correct? But as per the best practice, what we do means before you even switch to master branch, from the current branch, you can say like git rebase master. So this command should be executed from the current branch. So what this is going to do means if there is any incremental changes happen in the master branch, those changes will be added to your feature and it will get synced with the feature branch. That is how the process. And then you can switch to master branch and merge changes. So now at this point, your master branch and the feature branch base is same. It is already in sync. So it won't make any changes. Now, if you switch to master branch and perform the merge action, what will happen? What is status of master branch now? The master branch will be like this. So this is upon merging feature 1, correct? When you execute this command, what will be the status of master? It will be like this. Are you able to follow this?
Yeah.
Correct. So upon merging changes from feature 1, the master branch current status becomes like this. All the changes, whatever we made in feature, it will get updated in master branch. Now, in the meantime, if feature 2 also doing some activities. So let's say in feature 2, we are just adding some changes like the same. This is my feature 2 and feature 2's commit. Like this. So now, without rebasing, if you simply say git switch to master, and if I say git merge feature 2, what will happen?
This will be getting the conflicts.
No, I'm not talking about the conflicts here. Okay. The conflict, if the commits are updating in the same file and same record, the conflict occurs.
Okay.
Even if there is no same file changes, even if it is something new, changes has happened, they are considering the commit level, synchronization level. So at this point, what will happen means, upon this execution, your flow will be like this. Sorry, not here. Let me put it. Okay. So it will try to accommodate changes like this. For rebase. Okay. So this will create a conflict in the commit level, because if you see already master branch is having 5 commits, but your current feature 2 is not having the changes. So the feature 2 only knows only the initial 3 commits from master, and on top of it, it will accommodate the changes. And what are the new changes happen in the feature 1 that will be added at the end. So this is not in linear fashion, right? This is not the actual expectation, right? Because before you commit a feature 2 changes, master branches already update with feature 1. Correct. So all that you should do is, before you merge, all that you can do is you can simply run this command. Git rebase master. So when you execute this command in feature 2, what will happen means it will try to bring the changes, the latest change from feature 1 also into the feature 2 like this. And what are the incremental changes you made in feature 2 that get added at the end automatically. Hope you can able to understand the difference between this and this level. So initially, when you create a feature branch, the base of the feature branch is having only 3 commits from master. That is the base while creating a branch. Now, when master branch is updated with any new changes, you are trying to rebase it. You have to bring this to your feature 2. Now, this master branch is having F1 changes also. So you're trying to bring it in your feature 2 like this. And now this is considered a new base. And on top of it, what are changes you made here that will get added at end and this will get merged. So now upon merging, the output will be something like this. Feature 2. Hope you're clear with this.
Yes.
So that's what. So always you should keep your current branch in sync with the target branch. And it is used to prevent the merge conflict target branch. So let's say, for example, I'm trying to rebase it. While rebasing, if there is any issue happened, like already the master branch is updated the same file by feature 1, means when I rebase, the conflict will occur in feature 2 only, correct? And what are the issues happened, you can able to fix your merge conflict in feature 2, and once you fix the conflict, you can able to merge it to the master branch. So ultimately, it is used to prevent the merge conflict in the target branch. And it is also used to maintain the linear commit history. Linear means a sequential commit history without any deviation. So let me show you that with some examples now. What we're doing here. Let me go back. So now we have a branch. Let me add some commits here. Guys, hope I make things clear to all, right? Because your silence is something disturbing. And it, what is it called? CM1. I just simply may call it a CM1 for now. It will be the next file. Any doubt here? Hope you can able to follow what I'm doing now. If you have any questions, please stop me. And now let me create a new branch. Git branch feature 1 and feature 2. Now let me switch to feature 1. Currently I'm in feature 1 with the same level of commits as like master. 3 commits we have, and it doesn't sync. Now what I'm going to do means I'm going to make some increment changes here. So echo record 1 dot text git add and then git commit -m f1 cm1 feature 1's commit 1. Similarly, let me add one more file, add, and this is commit 2. All right. So now if I say git log 1 line, you can able to see your feature branch 1 is 2 steps ahead of your master branch. Now I can simply go to that branch like git switch followed by the branch name feature, sorry, master and I can able to check it out. And even before that, if you simply say git rebase master, see, current branch feature 1 is up to date. That's what it means. So it is trying to bring the change from master branch into feature, but it says it is up to date. So now go back to your master branch, git switch master, and say git merge feature 1. It is updated. Now let me switch to feature 2. And in feature 2, let's add some changes. Because if you see the log here, you can able to see it is having only 3 commits as per the initial level of master branch. Now let me add new changes here. Add and git commit F2 PM1, correct? And if you want, you can add multiple commits as per your need. As you say git log 1 line, you should be able to see there are 3 increment changes happened in this feature branch. It is not having any clue about master because master branch is already head of it. So now in this case, you want to check if there is any incremental change happened in the master branch or not. If there is any change happened, you have to bring it to the feature. So how to keep your feature branch in sync with the master branch means by issuing the rebase command. Rebase followed by the master branch, name of a branch. And this command should always be executed from the current branch. So from this feature branch itself, we can say git rebase master. Please observe the commit points, okay? That is what important here. Hope you are following this. I am ready to merge, but before I start the merge activity, I just want to synchronize. I want to keep my current branch in sync with the master. So if I say git rebase master, it is trying to rebase my master branch changes with the master branch. And now if you say it is successfully rebased, if you get the log here, you should be able to see initially your master branch was having 3 commits when you create a branch. And now your master branch was updated with the feature branch 1. And on top of it, your current branch changes, 3 commits happened. See how it is aligned? Initially, this was the base, and now this is rebase to this level. And if you say git rebase master, it is up to date now. So this is how it means my current branch is in sync with the target branch. And once I'm ready with the changes, if you want, you can verify the results also. Like if I say ls, I should be able to see what are the changes you made in the feature 1. It is up reflecting in feature 2 now. Hope you understand. Are you getting my point or not? These 2 files, w1.txt and w2.txt was created in feature 1, correct? Guys, are you following?
Yeah. Yeah.
So upon rebase, what are changes you have in master? It is just available in feature 2 also. So this is how we can share the workload. Okay, sometimes there will be some dependencies. Like I'm a developer working on feature branch, and I'm just waiting for some input files from other branches or other users. When they commit the master branch, I can able to bring it to my local branch and I can start working on it. So now you can do something like git switch to master, and you can say simply git. Here you can find your feature 2 now. If you say git merge feature 2, it should be successful and you should be able to see all the content. So now this feature 1, sorry, your branches are in sync. Feature 2 and master are in sync. Easy. So this is about the rebase. And while rebasing, when you give a rebase command, it is trying to bring the changes from the latest in from master branch into the feature 2. Like W1 text and W2 text are two different files. What if changes are updating the same file? In the case, you'll be getting a merge conflict in the feature 2 branch. And if any merge conflict occurs, you should know how to fix the merge conflict. And after fixing merge conflict, you can able to merge it to the master branch. So with this, we can able to prevent the merge conflict in the target branch. That's what the idea. So the best practice always perform rebase before any merge. Before merge, you can able to do it. Okay to all. Am I clear with this?
Yeah.
So branching, branching, we should take care of the merging, and while merging, if any conflict occurs, you should be able to handle it. And to prevent the merge conflict in target branch, you can use rebase. So apart from rebase, there's another interesting option also for merge. One is that is git squash. So git squash, it is a merge option used to combine the commits. Okay. So git squash means it is a merge option used to combine the commits before merging. So let's say, for example, consider, if you want, I can refer the same example here. Listen, please. Consider I have a master branch with 3 commits, and based upon that, I create a feature branch here. So what is the purpose of creating feature branch? Means developer wants to make some incremental changes on the source code repository. They can aim to make a number of commits on their local branch. Till they achieve the result, they'll be making a code change, right? Like F1, CM1. So like this, they can able to make a number of changes in their feature branch. Possibly so that, right? We can't predict how many commits they're going to use. Like for example, today I'm going to work for a particular program. In that program, I want to create nearly 5 functions. So what I'll do, I'll be start creating the functions and I'll be testing each and every function. Till I achieve the result, I'll be making the code change. And whenever I make a code change, I'll compile the program. And if there's any compilation error or syntax error, I have to fix that issue and I'll be committing it. Like that, developers are allowed to make n number of commits in their local repository or in the local branch actually. And once they're done with the changes, what they'll do, they'll try to merge all these things in the target branch, correct? So when they merge the changes from their feature branch in the target branch, it is not just about the data. Like for example, here, this is about data changes, the file changes, whatever they have. Ultimately, I need a file changes only. But if you simply execute the commit or merge command, it is trying to dump all the commits history into the target branch. Like for example, if I say git merge git switch to master and git merge feature 1. What will happen? What will happen? All these commit histories will be updated in master branch, right?
Yeah.
feature one. So it means we are trying to dump all these commit histories in the target branch. Do you think it is really required? Do you think it is really required?
No, I think.
We can't say no also, because it depends upon the strategy, depends upon the process you follow.
Okay.
Let's say, for example, consider this particular scenario. The last session we were talking about some branching strategies, right? Let's take any of this one. Let me consider this one, for example. Let's say, for example, here I have a master branch initially with 3 commits. Based upon that, we have an integration branch, and then a dev branch, and then dev branch 1 and 2. Now, in this feature branch 1, we were making some changes, like F1, PM1, 1, like this. And similarly, here also there are some changes. Please pay attention, all of you. In this feature 2 also there are some commits happening. Now, once the changes are ready, what we'll do? We'll be merging this feature 1 into dev branch 2, right? So it will get dumped here actually. Similarly, this changes also will get dumped here. Like this, if you have more than one feature branches, all the feature branch commit history will be updated in the development branch. Okay. And similarly, it is applicable for this level also. At this level also, it is applicable. So now this developer 1 also will be having the same level of changes, correct? And when both the developers are trying to merge the change to integration branch, what will happen? Again, this same history will be reflecting there. Hope you can understand the scenario now, how complex it is. Can you follow the scenario? And without proper knowledge, if you try to merge into the master branch, again, this entire thing will get merged into master branch. Correct? So this is what the default workflow when we talk about the merging. Merging is not just to merge changes, it is also going to carry forward your commit histories. So developers will make some code changes. Even if they miss a small semicolon in the program also, they'll try to recommit and test the changes. Because of syntax error, they might miss some semicolon, or they can have some small silly syntax issues and all. So all these things are no need to be highlighted in the master branch, right? What I'm going to do with that in master. So for the purpose, what we can do means we can able to use some squash option, which is used to combine the commits. So the process is something like this. So if you want to retain the commit history in the target branch, you can simply merge it. But if you think that commit history is no longer required, you can simply combine and merge it. For example, here for developer 2 branch, I need to capture the feature 1 and feature 2's commits. Why? Because as a reviewer, before I merge change from dev 2 to integration branch, I have to review the feature 1 and feature 2. So here at this level, I need all the commit history, because as a reviewer, I need to verify it. I need to review it. For the sake of review, I can simply merge all the things in dev branch. There's no issues. But now assume that the review is completed here. Once the review is completed, what we can do? Again, you want me to maintain all these things in the integration branch? No, right? So what I can do means, before I merge, I can simply combine these commits. So this will become developers 2 features. That's it. So what will happen now? all these commits, whatever we have in developer 2 branch, will get combined together and create one new commit point. That's what. So we're just trying to hide. We're just trying to combine all these commit points into one commit point. That's what squashing means. Similarly, this guy also, they can able to perform the same thing. Developer 1 features. So these things can be merged into the target environment. On that perspective only, if you see my strategy here, I have introduced this level. If you look into this final strategy, just consider, I have these many changes here, but I never mention all the commits. It's just like feature 1. Feature 1 means, assume that I combine all the changes from feature 1 and made one commit. Similarly, all the commits history from feature 2 has been combined together and created a new commit point. Easy? Are you getting a point or not? So ultimately, if you want to hide or if you want to combine the commits during merge, you can use squash. So let's say, for example, we are on which branch now?
So if we combine, so after combining the commits, so we can't trace the previous commits, right?
Yeah, we can't trace it. That is not required. If you look into a scenario, already the reviews
It's already reviewed.
then what is the purpose of reviewing in the integration branch? Correct?
Yeah, yeah.
So in integration branch, you have to review the changes of dev 1 and dev 2 altogether, not the features, right? It is already updated and reviewed in dev branch itself. That's what the scenario.
Understood.
So now let me show you, I'm not sure in which branch we are here, master branch. And git branch. I have 2 here. Git log 1 line. I have these new branches. Okay, now let me create new branch from here. Git branch, or you can say git switch feature 4. Okay, git branch feature 4 I'm creating now. Sorry. Oh, sorry, it is, I can see. If branch name is not present, it says invalid reference. It's a new branch. Just use -c to create new branch and switch to the branch. Now, if I say git log 1 line, I can able to see my current branch feature 4 is in sync with master. Now in feature 4, I can make some commits. So record 1. And then hit commit. And then what is it? 4 scene 1. Like this, you can add any number of changes as per your need. I'm just making some incremental changes in this data set. That's it.
Sai, your voice is very low. I can't even hear.
Can't even hear means for how long it's like this? Hello?
Yeah, now it's better.
Hello, is it better now?
Yes, much better. Thank you.
Okay. So let me add few more commits here. And now if I say git log 1 line, you should be able to see your current branch feature 4 is nearly 6 commits ahead of your master. Correct. Now I'm ready with my changes. So whenever you're ready with the changes, if you don't want to highlight all these commit histories, because ultimately I have a file created, cat file name. These many commits I made in the repository in this file. These are the commits I made for all these things, right? So I am not concerned about the commit history. In the case, what I can do means I can simply say git switch to master. And while giving your merge command, git merge, followed by the branch name normally will give, right? Feature 4. This is what the command we give for merging. If you do this activity, it will merge the entire commit history into the target branch. But if you want to combine all the commit histories, incremental changes, you can use a param called -squash. Squash followed by the branch name. So the squash command or option will try to combine all the incremental changes, commit history, and creates one new commit history. If you execute this command, it will ask for a commit message now. See here, it is just updating the branch. But if you say git status, it says we are on branch master, changes to be committed. So what are the incremental changes you made? All the incremental changes are ready to be merged with master branch, but it is waiting for the new commit point. So just give a commit -m followed by the commit message like combined. You can give any message. Feature 4. That's it. Now it is updated. And if I say git log one line, you can able to see it has created only one commit history. Can you see this? All these things are combined together and create one commit point. So this was the base when you create a feature 4. And these are the incremental changes. All the incremental changes from your feature 4 has been combined together and come up with a new commit point. That's it. Now my master branch is free from all the unwanted commit history. But if you say the file here, cat if1.txt, you can see the content. There is no change in the content. Content remains same, only the commit history varies. And even if you say git show this particular commit ID from the master branch, you can able to see what are things we made in that commit. It's a combined commit from feature 4, and these many records are added as part of that combined commit. You see? So ultimately, our intention is to keep our target branch commit history clean without dumping all the commit histories there. And it's a very, very important scenario for maintaining the statistics of your target environment, because unnecessarily, you're not going to dump anything there. So if you look into this workflow also, all that I did is assume that I have some changes, incremental changes in lower branches like this. We have a lot of changes in the lower branches like this. So now assume that I am for team 2. In team 2's integration branch, there are 2 developers, developer 1 and developer 2. And each developer have their own feature branches. Now I'm going to combine all these features into one in development branch. That's what it is, feature 1 and feature 2. Like I can say like D1 feature 1 and this is D1 feature 2. Similarly, I want to combine this as D2 feature 1 and D2 feature 2. Got it? I just combined all these things into this level. So similarly, what I can do, I can able to maintain the same level here. This is D2 and this is D2, D1 and D2. So like this, developers branches are ready in this integration branch. So now this will get merged into dev1 feature 1 and dev2 features. So like this, try to combine here at this level also, we just combine these two things, right? And update it here. Similarly, we combine these two things and update it here. That is how we are just trying to combine the commits and creating a new commit point. And now if same thing goes to release level, what will happen? Do you want to keep all these things as it is, or you want to combine these two things? That matters. So my team 1 is having 2 changes, team 2 also having 2 changes. I want to combine these 2 changes and create one commit point here. That's what team 1 changes. Similarly, the team 2 changes will be available here. And when this goes to master branch, again, I'm going to combine these 2 commits and create one new commit point called CM4. Or it can be a release number, whatever it is. So please try to understand, okay, how we are just maintaining the status of a master branch. In master branch, I don't have any dump references of all these commits. It's not required. Only one commit will be there on top for this particular release. Release 10, 23, like this. So for this particular release, I have these many changes. That's how I just maintain the commit history on top. Are you able to understand this process?
Yeah.
Any question? Any question? Guys, if any one of you are unable to follow or understand, please let me know. So your silence says many things, but it's okay. So that is what. So that is the reason. As a best practice, what we do means before you merge anything target branch, if the commit history is not longer required, you can simply squash it. That's all. And we have another benefit also here for squashing, because at in a real-time environment, anything might happen. We have 2 teams involved in this release activity. For this current release, October 23 release, there are 2 teams working on their code changes. Each team have their own developers and each developer have their own features to work on it. So I'll give you one real-time scenario here. Assume that both the teams are ready with their changes and their changes are already merged into the release branch. So team 1 change and team 2 changes are already merged in master branch. Now it is ready for production release. That means it is ready for merging to master. At that point, due to some reason, team 2 is having some conflict. Management or release manager decided not to send team 2 changes for now. We want to hold it for this release. So what we can do now? What we can do now? I have 2 commits in my release branch. I have 2 teams ready with their changes. Out of these 2 things, I want to send only team 1 changes to production environment. So what I can do?
You can roll back to that team 2 changes commit.
Yes, that is one of the options, but I don't want rollback also because it is not like a issue, right? We're just holding it. So what I can do means there is a concept called cherry pick. Cherry pick. So we have something called git cherry pick followed by the branch name or a commit ID. I see commit ID. So here in this case, we use git cherry pick followed by the commit. Assume that this is a commit ID we have. We can specify it here. So in this case, what will happen means it is used to pick up only the commit you mentioned in the cherry pick, and that will be merged in the target branch. So usually we give merge command, right? Merge followed by the branch name. Similarly, you'll be giving a git cherry pick followed by the commit ID. So only this particular commit will be merged into the target branch. So this is how we can able to select all the changes from team 1. But assume that if you're not using the squash option and you dumped all this commit history in the release branch like this. Okay, what will happen then? You have to cherry pick each and every changes independently, right? Which is very critical, very much difficult, or it is not all recommended also. So basically in real-time environment, we never recommend cherry pick option, because cherry pick, if you miss even one commit also, it will create a lot of conflict. So as a best practice, we never encourage people to use cherry pick. If they follow proper squashing mechanism, and if they're sure about what they're doing, they can go with cherry pick. But without squashing, if they simply dump all the commits in target machine, target branch, and if they want to select a specific commit from there, means we never allow that. Clear? So cherry pick also, we have an option to merge changes to target branch. It is based upon the commit ID, not based upon the branch name. Is that clear to all?
Yeah.
Interesting or boring? Or you want to have some break? What's happening there?
Yeah, need a break actually.
All right. So if you want to have a break, just have a quick break and come back. How much time you need?
So
Sorry?
10 minutes, please.
10 minutes, right? Okay. Yeah, go ahead. So shall we? Guys, am I audible to all? Shall we continue now?
Yes, yes.
Yes, sir.
All right. So far we were talking about the Git branching process, starting from the branch creation, merge conflict handling, as well as we discussed about rebase and squash, right? So this is what we should understand whenever we talk about the branches. Like once it is done, next we'll see how to access the remote repositories. This is the next topic, the last important topic in Git. So working with Git remote repository is a very important task, because whatever activities we were doing now, it's all at the development level, at the developer's machine. Any individual developers, they can able to work on their changes and it will be available in local machine. But as we discussed already, Git is one of the open source distributed version system. Distributed means the changes, whatever you have in your local repository, it can be merged or published to the target repository, which can be in any remote servers. So whenever we talk about remote repositories, source code repository, we use GitHub. GitHub is one of the remote repository for managing source code. Apart from GitHub, we have many other repositories in market. Like if you say GitLab, or if you say Bitbucket, or you can say something like Azure repositories, or we can say like AWS code commit. Like this, there are various source code repositories available which are considered as a remote repository, and all these repositories are using Git as a base. Okay, what are the commands we have used so far? What are the activities we perform? Everything can be performed in any of these repositories, and all the Git commands will work here also. Got it? So today in our demo, we'll be working with GitHub, and in real-time environment, you might be getting opportunity to work with any of these repositories, but the working process, principle, everything is same. Only the user interface will be different here and there. Apart from that, the process remains same. So before you actually work on this repository, you should understand the developer's workload properly. Like if you say here, so whenever we talk about the development, application development, developers might be working on some new project, right? I told you already. Or it can be something like enhancement project, enhancement or bug fixing. So almost, if you're working for any service-based industry, or if you're working for any product-based industry, so you'll be working, I mean, developers will be working on some enhancements of the existing project, or they'll be creating altogether a new project. So you should be able to handle the remote repositories for both these scenarios. That's what the point. So if it is an enhancement-based project, means the source code repository must be already present in remote repository, correct? So that we have to bring it to the local machine. Let's say I'm a developer, I want to work for some enhancement project. So the project source code is already available in remote repository. I have to bring that repository to my local machine, and I'll be making some changes. So once my changes are ready, I can again publish my changes to remote repository. That is one scenario. In the scenario 2, the source code will not be there. Correct? Because it's altogether a new project. It is created and tested in local machine, and then published to remote repository. Correct? And in remote environment, in remote machine, you'll be having only the empty remote repository. A repository alone will be having, it won't have any content. So this is what the basic difference while working in the enhancement project or new project. Any question here? Any question in this?
Yeah, I have a question for this new project. So let's say if we have a local repository and some contents in it, and once we connect to remote repository, so we execute that push command, and then it will be visible in GitHub account when we push it, or we have to clone it from the GitHub and then make the changes and then push it.
That's what the point here. That's the reason I just gave these scenarios. So whenever we talk about the enhancement project, I told you source code is already present in remote repository. So first you have to bring that changes to the local machine and you will be doing it. So if you recollect my last day session, we were talking about many Git commands, right? So we discussed about Git commands like Git clone, Git push, Git fetch or pull. Remember?
Yes. Okay.
So what I said about Git clone command, using Git clone, we can able to copy the entire repository from the remote environment to the local machine. So if you're working on enhancement project means you won't create any project or any repository in the local machine. You'll be cloning it first. Once you clone, the entire remote repository will be copied to your local machine, and you can make some incremental changes in the local machine and commit the changes. Once the changes are ready, you can able to push it to the remote repository again. That's what the push command means. This is at the enhancement level. But if you're trying to create a new project altogether, you can't clone it because nothing in the remote environment. You should do init. You'll be initializing the repository in local machine. You'll be making some changes. Once changes are ready, you can link that local repository with the remote repository and then publishing it to the remote repository. That's what the workflow here. And apart from that, we have discussed about something related to fetch and pull. Both fetch and pull are used to handle the incremental changes from the remote repository. Clear? So I'll show you how it works. First, I'll show you how to work on this level. We'll create some remote repository and show you how to create a repository in remote environment. And then we'll talk about the scenario. Where is it? So do you remember your repository name, the source code repository, whatever I pinged you last week? Guys, last week I pinged you on repository, right? Do you remember the name of repository by any chance?
Yes, sir. Yeah.
Or you want me to share it again? Sorry, who's sharing that? Are you sending the repository link now? Anyone pinging the link now in chat window? So now, yes, this is what I'm trying to show you actually. So this link, hope you all have access to this. It's a public repository. So all that you can do is you can able to get into this repository to access all the class nodes, whatever I'm going to share with you. So now how I create this repository, I'll show you now. So let me put it in this class nodes also. Okay. So now in this case, listen carefully. I'm going to create one repository. So in order to create a repository, first log into GitHub account. Don't try anything now, just listen. Just log into GitHub account, and on top, you can able to see there is an option to create new. So when you click on this option, you can able to see there is an option to create a new repository. Can you see this? So just click on create new repository. It will take you to a page from where you can able to create a new repository. Here it is. So click on new repository. It will take you to this page, create a new repository. And here it will be pointing to your ID. And then you can able to specify the repository name. Let it be like test repo 1. I'm going to create here. And description, just add a description here, valid description. And make it as a public repository. And add a README file also. README file in the sense like if you want to maintain any documentation purpose to describe about the repository, you can able to add a README file. And optionally, you can add some git ignore file also. Like we discussed about git ignore, right? That's also possible. From here, you can able to choose any of the templates. And you can able to create a git ignore file for Java applications or any type of applications. So to create any repository in remote environment, these are the parameters required. Like give a valid name of repository. You can give this description optionally and choose the access type, whether it is your local or, I mean, public or private. And enable this README option and create a repository. So in any remote environment, if you, especially if it is GitHub repository means, by default, it creates a branch name called main branch. Okay, main is a default branch name for GitHub. Like in local machine, when you create a repository, it creates a master branch, right? It creates a master branch in local. But if it is a remote repository, especially if it is GitHub means, it be creating a main branch. Just a naming convention, name changes. Apart from that, everything is same. Now that we have created this repository with just a README file, and this is a file content. The file, whatever description, whatever gave based upon description, we created one README file. So now from this repository, if you want to add a new file, okay, as I said already, whenever we are working on a repositories, we are not supposed to directly update the main branch or master branch. So all that you can do is you can create a new branch and start working on it. Once the changes are ready, you can able to merge it to the main branch. So let's say, for example, I have a main branch here. If you want to create a new branch in remote environment, click on the branch name and you can able to see there is an option to create a branch. So just type the branch name here, which you want to create. And then click on create branch. See, now a new branch has been created. And we are on branch 1, I mean feature 1 here. Out of that, main branch is considered a default branch. So now we have feature branch 1. And once the branch is ready, you can able to add some commits here. So let me add a new file. Let it be file1.txt. And I can able to add a number of changes here as per my need. Once changes are ready, click on this commit changes. This will just commit your file with a valid commit message. Give a valid commit message and commit it. That's it. So now that we have created one commit in our feature branch, and it is giving a message like this branch is one commit ahead of main branch. That is all. That is what the difference between working in CLI command. This is a command utility, right? And this is a GUI based. So GUI based means it will be more intuitive. It will be more informative. And it will be very easy to work. Using some mouse click events, you can achieve many tasks. But what are things you learned so far? That's what we're going to do here also. Like creating a branch, adding a commit and all. So now you can see my feature 1 is one commit ahead of main branch, right? And if I switch to main branch, you can't find that file 1.txt. And it is giving recommendation. Feature 1 had recent pushes 1 minute ago. If you are ready to merge my feature 1 into main branch, I can do it through a pull request here. So pull request means it is a request that is created by the developers who made the source code changes in the feature branch. If they want to merge their changes into main branch or master branch, they can create a pull request, and that pull request will be sent to the reviewer for approval purpose. Once they approve, then only the changes will be merged into the main branch. Got it? It is one of the important process we follow here. As like that, we never update or merge any changes in the main branch. It should be done only through pull request approval. So in order to create a pull request, you can simply click on this command, compare and pull request. And a pull request form opens. Here, developers can give all the descriptions. Like in a real-time environment, developers will be working for a particular release. So for which release they are making changes, and what are the files they updated. In each and every file, what are changes they made, whether they tested all the changes or not, what is the test result, what are the test data they used. All the information about that particular release changes will be updated here for the review purpose. And based upon information, they can simply click on create pull request. And to whom they want to send this request, that will be decided by this reviewer actually. So you can see here the reviewers. As of now, there is no contributors to this project. But in real-time environment, when you click on this reviews option, you can able to see the list of contributors. Their email IDs will be available here. Your managers or reviewers email ID. Select that user and click on create pull request. So it will create a new pull request, and while creating a pull request, it is validating the scenarios like, is there any branch conflict or not? Everything will be verified. Because during merge action, it should not create any conflict. So if there is any conflict occurs, it will highlight here itself. So before you execute a pull request, the conflict can be resolved. Clear? So now that we have created a pull request, and if you're okay with this, we can simply click on merge pull request and confirm merge. See, it is done. Pull request has been completed now. Changes are merged. And now pull request successfully merged and closed. And here you have an option to delete the feature branch, because as I said already, the feature branches are always considered as a short-lived branch. Once you merge your changes into the master branch, if the branch's feature is no longer required, you can just delete it. That's it. I've just deleted it. And now if I go to my repository level, I have only one main branch. And what are changes we made in feature branch is already merged to main branch now. Understood? Can you able to understand the workflow here? How to work in the remote repositories?
Yes.
Yeah, yes, sir.
So there are two things to consider here. One is developers can able to create their own feature branches. But if they want to merge their changes into main branch or master branch, it should be done only through pull request. And that pull request should be properly approved, and then only it can be merged in target branch. Easy? So now assume that this is a source code which I want to use in my local machine. So if you want to work on this repository, if you want to clone this repository local machine, just at the repository level, if you see, there is a code option here. And if you expand this, you can see there is a URL, HTTPS URL for this repository. So this is what we call as a clone URL. Just copy this URL, and here you can able to use git clone command followed by the URL. Git clone followed by the URL. So if you execute this command in local machine, just open git bash. Let me come out of this previous repository, and let me create one more directory here. So now I just created a simple folder. In this folder, I can simply say git clone followed by the URL. So it is trying to clone the repository from my remote server, and it is completed. Now, if I say ls, I should be able to see the test repo 1, whatever I've created here in my remote. And if I get into the directory, I should be able to see there are 2 files in the repository. It is having a main branch, and it is having 2 files, readme file and file1.txt. So this is what the clone activity. Since it's a public repository, it is not asking for any credentials. Directly you can able to clone it. But if you want to push it to the remote repository, you need some access token. Directly we can't push it to the remote repository. With some access token, we can able to do that. So assume that I have my remote repository which I cloned, and if I say git status, you can see we are on main branch, and your branch is upgraded with origin main. It is not just main, it is origin/main. So what does this origin means? Origin is nothing but the alias name or alternate name to your remote server or remote repository. So there is a command called git remote-v. Git remote-v is a command that is used to get the list of remote repositories which are linked to your local. So my remote repository is this one, which I can able to use for fetch and push event. And the alternate name for remote repository is origin, which is created by default. So it means your current branch is upgraded with the remote repository's main branch. That's what it means. Easy. Am I clear with this? Now, what I can do, I can able to make some incremental changes here. In my local repository, I have only one branch. If I want to work on this, what should I do? Can I directly update, work on this?
Yes.
Can I directly work on this main branch?
No. You
No,
have to
sir.
create
To create a
Create
future
one
branch.
more.
Yeah. So what I
feature
can do
branch.
means I can create a feature branch. Git switch -c. I can say like local feature 1, for example. And now if I say git log 1 line, what are the commits we made? It is available, and on top of it, you can see your local feature branch and your local main branch and the remote main branch and its head pointer are in sync. So it means your local branch and the remote main branches, everything is in sync now. And if I say git status, sorry, you can able to see this is status working tree is clean because we never made any incremental changes. It is clean now. So let me add a new changes here. Echo record 1 local file1.txt. I just created this file and let me add it. So all these things are happening in my local feature branch only. And git commit -m. This is local file1 created. That's it. So I just made one changes here. And if I say git status now, it should be clean. And if I say git log 1 line, your current branch is one step ahead of your remote as well as local main. So now that I have some changes available, so how I can able to push it to remote server? So there is a command called git push -u origin main. So if you execute this command, it will try to merge your changes, push your changes to remote repository, but I don't want to directly update the main branch. I want to create a new branch called local feature 1. So in my remote repository, in my origin, that is the remote repository. This is a remote repository, right? In this remote repository, I want to create a new branch called local feature 1. And in that new branch, I want to push my changes. So this is what the scenario. Understood? So command here is first clone it, and you can able to make local changes in a new feature branch. And then what you can do, you can able to perform git add and then git commit, and then you'll be issuing git push command, git push -u origin branch name. So what we're going to do here is, what are the changes you made in the local machine? In this local branch, you are trying to update it to your target. Any doubt at this level?
Yeah, actually, when you clone it, right, remote repository in your local. So before cloning it in our local, it must be the same directory, right? Where we have in the remote.
Yeah, it is in test repo.
And it should be present in remote. Okay, all right. And then we can clone it. Okay. Yeah.
So now that I want to push these changes, just observe properly. When I try to execute this command, it is trying to push the changes in remote repository. Okay, and it is done. And in my remote repository, if I just see here, a local feature 1 has recent pushes less than a minute ago. And if you refresh the page, you should be able to see the branch local feature 1 is available here with the new file, local file 1. So if you want to merge it to the master, what you should do? If you want to merge it to main branch, what we can do?
You can compare and pull request.
You can simply create a pull request and merge it.
Yeah.
But point here is, when I execute this command, git push command, when I execute this git push command, it was not asking for any credentials. Directly it is pushing changes to remote repository. So what it means? The credentials, whatever needed for the remote repository, it is already stored in my local machine. In any Windows credential manager, the credentials will be stored. So let me show you that credential manager first. So if you go to this Windows credential, you can able to see there's a credential created for this. For my remote repository, it has created, I have stored one username and password. So this is already available in my local machine. Because of this only, it is not asking for the credentials. Now, let me remove this. Okay, I just removed it from my credential manager, and let me make some more changes in the same repository. Let me commit. And now let me push this feature 1 again. So it means for your level, for the very first time when you try to issue push command, you'll be getting something like this. So now it will ask for the credentials. Either it can be a token or it can be a login process. So you have to authenticate yourself, right? Not to handle your remote repository. So there are two options available here. Either you can have an access token to log into your GitHub repository from your Git bash, or you can simply sign in with your browser. There are two options. So sign into browser means very simple. If you click on the sign in with your browser, it will just open up a GitHub page. You give your credentials to log in. That's it. It will authenticate. Apart from that, you can create some token also. So token sense, if you go to repository level, on your remote repository, you can see there is a settings, account level settings. Click on the account level settings here. And in the account level settings, if you scroll down, you can see there's something called developer settings. I repeat, log into GitHub, and at the account level settings, if you scroll down, you should be able to see something called developer settings. And in developer settings, you can able to see personal access token. And click on this token classic, and it will open up this page. And here you can able to specify generate new token. Click on this create new token and verify it once. And now you can able to specify the token name, which token you want to create. Like this. And you can set some retention period for this token, like 7 days or 30 days or no expiry. And using this token, what you're going to do? You're going to handle the repositories, right? You can able to work on your repositories, like adding the content or updating, creating branches, pull request creation. All those things can be possible with the help of token. So enable this repository option and simply click on generate token. So this token will be generated for you now. So using this token, you can able to log into your GitHub account. That's what the personal access token. So usually we never give any credentials like username and password. It will be a personal access token you have to create in your GitHub account. Is it clear? See here, it is asking for the username. When I click on that token, it is asking for the username. So username is same as like Loxai ETA. And it is asking for the password. Password is nothing but the token, whatever I copied here. Copy this and enter it here. So once it is done, then my push action is completing here. So user cancel the log and it is done now. It has created the process. So if I go to my remote repository and verify the result, where's that remote repository? Can you able to see this? So you can able to quickly handle it. So there are two things to consider here. One is how to access the credentials. That's very important. And then how we can able to publish the changes to the remote repository. That is another important thing to consider. Okay. Any question? Any question here? Please let me know. So my repository is up to date. My remote repository is up to date when I try to push again. That's what. So as a best practice, what we do means we first create the token. And when you try to push the change from local machine to the remote environment, we'll be using that token for authentication purpose. Once it is authenticated, your push action will be completed successfully. And also the token will be stored in the Windows Credential Manager. Okay, this Credential Manager, if you restart, you can able to see the credential available here. Then after you don't need to give any other credentials. Okay, it's a one-time activity. So command here is git push -u origin followed by the branch name. -u means it is just an instruction which is going to capture the user credentials from the credential manager. Using same credential, you can able to connect to this origin and push the changes. So can you able to see now? Now that we have the changes ready in local branch. So if you want to merge these changes, you can simply click on compare and pull request, create a pull request. And as far as this pull request is concerned, we have two files updated, local file 1 and 2, remember? So just merge it. And upon merge, if you want, you can able to delete that branch. It's done. Easy. Is it clear? Hope you understand the workflow, right? How to clone the remote repository, make some changes and push it to the remote repository.
I have one question. So after merging, so we need to delete that feature branch, right?
Yeah, in a remote environment, that branch is no longer required.
Okay.
If you want, you can remove it. Otherwise, you can keep it there.
Okay.
Because features are just like a short-lived branches. Once it is merged to master, then there is no point in keeping it. If you want, you can create a new one. Easy?
Yeah, okay.
All right. So this is about the repository handling, how to create a remote repository, clone to the local machine and push it back to the remote. And next we'll talk about something related to your fetch and pull, or fetch and pull. So what I said about fetch and pull, it is used to handle the incremental changes, right? Like for example, in your remote repository, if there is any incremental changes happened, that changes will be updated in local branch or local machine by using this fetch or pull. So if you use git fetch means it is just to check the incremental changes in the remote repository. It won't update your working directory. But if you use git pull command, it will check for the incremental changes and it also updates the local and remote working directory. That matters. So now if you consider my repository in this case, I'm on local feature 1. If I say git switch to main branch, and if I say git status, I can see that your current branch is up to date with the origin. But if I say ls, I can see only file1.txt. But my remote repository is already ahead of your local now, correct? In remote repository main branch, I have these many commits happened. But it's all not reflecting in my local branch. And status also says it's up to date. So it means your local branch and remote branches are not in sync at this point. So if you want to check if there is any changes happened in the remote repository, you can simply say git fetch command. Git fetch. So the git fetch, what will do means it will try to fetch the changes from the remote repository if there is any incremental changes happened. Now it noticed that there is some incremental changes happened in the remote repository. And if you see here, if you gave ls, the changes are not in the working directory, but it has fetched in the local repository. And if I give git fetch again, see, nothing is happening because already it has identified the incremental changes from the remote repository and it just updated the local repository. That's it. But it does not update to the working directory. If you want to update the working directory, what you can do means you can give git pull. See, it has updated the local repository here along with the changes and the working directories. Now, if I say ls, I should be able to see those files. So that is a basic difference between git fetch and git pull. So git fetch will simply check for the changes. If there is any incremental changes available, it updates the changes in the local repository, but it will never update the working directory. If you want to update the working directory with the incremental changes, you should use git pull only. So if you want, I can repeat this task for you. Consider I have a main branch. Let me add a file here directly for this demo.
So
Okay.
why we need that git fetch? So if git pull is done that job.
It is just to check, that's all, nothing else. If you
Okay.
want to know, let's say before I pull anything, I just want to know if there is any changes happen in the remote repository or not. If you really want to do it, just use directly use git pull. So now you can see I just created one file here in this main branch. And now if I say ls, the file whatever I created here, temp file 1 is not available here. So if I want to bring it, what I can do, I can simply say git pull. See, the git pull is checking changes as well as it is updating the entry in the working directory. So point here is, if your intention is just to check for the incremental changes, you can use git fetch. If you want to check the changes as well as if you want to bring the change to the working directory, you can use git pull. So technically this git pull, it is used to perform git fetch as well as git merge. It is going to bring the identify changes from the remote repository, and also it's going to merge into the working directory. That's what the process behind git fetch and pull. Clear?
Yeah.
Fine. So this is about handling the repositories. Okay, if the repository is already available, we can clone the repositories, add some changes, push it back to remote repository, and also handling the fetch and pull activity. What if it is completely new repository or a new project you have? In this case, you'll be having only the empty repository in your remote environment. So let's say, for example, let me create a new repository here. Just go to this add new repository and specify the repository name. So I'm going to create one empty repository without any file. So let it be like test repo 2. Just give the repository name. Don't give any description. Make it as a public repository and don't need to create any README file because my intention is to create an empty repository. Okay, just specify the repository name, make it as public and create a repository here. So when you do that activity, you can able to see this is what the status of the repository. It is not having any commits. So at this point, if you want to add any commits, these are some recommendations given by GitHub. So you have an option to create a new repository on your local machine and then add it to the remote repository. Or if you already have a local repository, means you can simply add it to the remote repository and push it to the remote repository. Or if you want to import the repository from any other repository, you can able to use import option. So we'll be working on this process now. So I'm going to create one new repository in local machine, and that I'm going to add it to the remote. So you know how to create a remote local repository, right? So let me create a directory. So if you want to create a local repository, you can simply create a folder and give git init command there. Git init. That's it. So it has initialized one new empty repository. That is what even recommended here also. Git init, and you can able to add some changes, commit the changes, and then you can able to add some, rename the branch, and then you can use git remote add commands. So issue git init, git add, and git commit. And then there is a command called git remote -v. So this command is used to get the list of remote repositories attached to local repository. Okay. And if you want to add any new remote repository to your local repository, you can say git remote add origin followed by the URL. Or if you want to remove the repository, you can say the same. Instead of add, it will be remove command. So this is a command it is used to link your local repository to remote repository. So I'll show you that once. Listen, please. So I have my local repository just created. I think I don't have any files created yet. Let me create a new file. Go record one, file one dot text. Let me add it to the local repo in the master branch, and let me commit this local repository. CM1 from local master. That's it. Now my repository is ready. As per the recommendation, the repository is ready with the content. And they are giving a recommendation to change the name of a branch. So there is a command called git branch -m followed by the name of the branch. So whenever you create any repository in your local machine, the name of a branch is master. But as per the GitHub standards, they want to maintain the default branch name as main. That is what they just recommending us to change the name of a branch. So if you say this, now the branch name has been changed to main. It is just for their standard, okay? It is not mandatory that you should rename it. If you want, you can able to say like this itself. You can able to maintain master branches there also, it's possible. Just to maintain their unique standard, they just recommend us to change the name of the branch. It is completely optional. And simply run this command, git remote add command. Because at this point, if I say git remote -v, sorry, git remote -v, there is no repositories, remote repositories linked to my local repository, correct? If you want to add it, just execute this command, git remote add origin followed by the URL. And now if you say git remote -v, you can able to see the origin has been added for this local. You see? So once you have this available, you can simply issue the git push command, like git push -u origin master. So these changes, whatever you have in the local, it will get merged into the master branch in the remote repository. And if you refresh the page, you should be able to see the changes here. Easy. And at any point of time, if you want to remove the link, I have one remote repository attached. If I want to remove it, I can simply say like git remote remove origin. That's it. Now if I say Livy, it is not attached. So like this, at any point of time, you can remove that link actually. That's not an issue. Like this, a same repository can be linked with more than one remote repository also. That's possible. Like for example, git remote add origin. Similarly, I can add one more origin for repository 1. That is also possible. And if I say V, I can able to see my local repository is linked with more than one remote repositories with 2 unique origin name. So in a multi-repository environment, okay, if your source code, if you want to push it from multiple remote repositories, you can able to attach or link all those remote repositories to this one. So if you want to push your changes to a specific thing, you can use the name, alias name there. Git push origin or origin 1, like this. So it's all in a multi-repository level, developers can able to make use of it. Any question? Any question here? That's all. So that's all about handling remote repositories from your local machine.
Can you tell me origin 1 and without number? Origin is command, right? You can
Origin
use...
is not a command. Origin is not a command. It is just an alias name for your remote repository. Git remote add is a command.
Okay.
I have a remote repository. Every time I can't use the complete repository name, repository URL. So that I just assign one new name, alias name for that. You see?
Yeah, but
Fine. So this is about your repository handling, remote repository handling. Any question?
I have one question. Same like a different repository, how we can manage different users? Like if I have two account, how can I push from one system using the different credentials?
See, how can you have more than one credentials?
Like, if I one I use for my work or other one I will use for my personal project or something, if I can switch between two user credentials like.
Yeah, so in that case, your repository link, URL, everything will be different, right? For the specific user,
Yes.
right? So whenever you try to push your changes to the remote repository, it will ask for the credentials. Just give a valid user ID and credential of the particular account.
Okay, each time it will ask or like.
No, it's a one-time activity. It will just store there. And if you want to handle with multiple accounts, in the case, every time you have to confirm that to which account you are pushing.
Okay.
That matters. And at enterprise level, we'll be having one-time setup for accounts because we never have multiple accounts at the enterprise level. Correct? Matters. But you'll be working with multiple repositories there. Fine. So that's it about your remote repository handling. And the last topic which I want to highlight here is about Git stash. So Git stash is another interesting topic in Git. Okay, what is the purpose of Git stashing means? It is used to save the uncommitted changes to a temporary area or to a branch. Okay. So what does the uncommitted changes means? So whenever we talk about repository, let's say I have a master branch, and in this master branch, you can have a number of commits. Like this. So it is not mandatory that whenever you add anything to your working directory, you have to immediately commit it. We can able to add it to staging area. And once you finalize the process, you can able to create one new commit point. So not like for each and every line of code change you need to commit. So you can have some unit of task based upon you can able to commit it to your remote repository. So now the point is I have a remote repository. I have a repository. With a master branch with some commits. And I've created a feature branch, feature 1, which is having the same entries. Now, I'm just making some changes. And I'm just giving it add. I'm yet to commit, okay? I'm just trying to make some changes, and what are changes I'm making, I just want to add it to staging area. After proper testing, I just want to go to commit. Till then, I don't want to commit anything. This is what the actual process in real time. So in such scenario, while I am adding the entries to staging area, all my records will be available in staging area only. While I am working on this particular requirement, all of a sudden, if I'm getting any new requirement, like it can be a production bug issues or it can be some sort of enhancement or whatever it is, but it is something on priority. Some ad hoc requirement will be coming, right? So in that case, for that particular ad hoc requirement, I have to create one new branch. Okay. And this branch also will be created based upon the master branch. So it will be having all these initial commits, whatever we have for master. And I need to focus on this particular branch. Like for the ad hoc request, I'll be making some changes. But the point here is the switch between the feature 1 to ad hoc. It is not possible if there is any uncommitted changes are present here. Always, whenever you work in any repository, if there is any uncommitted changes in the current branch, you're not supposed to switch to another branch. It will create a conflict. If I want, I can show you this with an example. So I have only one main master branch with this commits, I believe. Only one commit. Now let me create a new branch. Git, what is it called? Branch feature 1. And let me make some changes here. Like go, sorry. Git switch feature 1. And let me make some changes. And I can add it to staging area. Similarly, I can make one more change and I can add to staging area. Like this, I can able to add a number of staging area. If I say git status, it says there is some uncommitted changes in my repository. Now I'm getting some ad hoc requirement. But without proper testing, I don't want to commit it to my local repository. Okay, so this is the uncommitted changes. So in this case, if I simply create a new branch, git switch -c ad hoc branch 1. If I create a new branch and if I switch to that, see, a new branch has been created and the control has been switched to that branch. But now if I say git status, see what is happening. What are the changes I did in my feature 1? It is reflecting in ad hoc change branch. But this change is not meant for this branch, right? Are you able to understand the scenario here? Guys?
Yes.
So whenever you try to switch your branches without committing the current branch, the changes will carry forward to the new branch also. But these changes are not meant for this ad hoc branch. It is meant for my feature. So this is a conflict actually. So in order to overcome this, what I can do, I can simply switch back to feature branch. And here you can see there is something added. This file has been added, but it's not committed. So I have to commit this. And then only I can switch to new branch. This is what the main issue. Whenever you try to do a navigation from one branch to another branch, ensure that your working tree is clean. If there's any uncommitted changes in the current branch, it will reflect in the new branch. That's what the point. But now the scenario is I even don't want to commit it. Okay, my requirement is I don't want to commit this here. So how can I able to switch without committing the changes? For that I can use git stash. So what I can do here is from this branch, before I move to ad hoc branch, I can simply issue a command called git stash command. Git stash save followed by the message like created file 1.txt, some message, commit message actually. So what are changes you made in the staging area, it will get copied to the temporary area. That's what it will move the changes from staging area to temporary area. That's it. So let's execute this command here. I am on feature 1 and I have some uncommitted changes. So I can simply say git stash save followed by the message. This message is something optional, but if you give a message, it will be having some relevance to that. stashed for created a file1.txt. That's it. So now the saved working directory and index state on feature 1. So now if I say git stash list, I should be able to see the stashed entry. And if I say git status in this branch, it should say the clean status. So all the uncommitted changes are moved to a temporary area in my .git folder, and it is uniquely identified with the help of this identity here. Git stash @0. Similarly, if I have one more change here, like for example, if I create one more file, and if I say git add, now the status becomes uncommitted changes are there in staging area. That's after text. I can simply say git stash for file2. And if I say git stash list, I should be able to see my stash is having 2 entries. Always the latest stashed entry will be referred by using index 0. So this is the latest one. F2 is the latest one, which I stashed, right? So that will be identified by stash 0. If I stash one more element, it will become 0 and it will get added more entries here. So this is how the stash lists are maintained internally. It is something like last in, first out principle. Any question? So where all these things are stored means it is stored in the .git folder. Okay, that's what the git metadata folder is maintained there. So at any point of time, if you want to bring it back, I can simply use a command called git stash apply. Git stash apply. So the git stash apply command will bring back the latest changes from the stash list into my staging area. See here only f2.txt has been moved back. And now if I see the list, in the list change will be there. So it means the apply command will simply reapply the changes. It won't delete anything from the stash entry. Okay, it won't delete anything from the stash entry. After reapplying changes, if you want to delete that entry from here, you can use something called drop command. So git stash drop. See, the F2 changes, whatever we had in the temporary area has been deleted. So drop is used to drop the latest entry from stash list. Okay, so that's what. So if you want to create a stash entry, use git stash followed by the stash message. And if you want to reapply changes to this staging area, you can use git stash apply command. That apply will bring the latest changes to the working or staging area. If you want, I can stash it again and show you. Git stash save f2.txt. Now again, if I say git status, it will be clean. And if I say git stash list, now I can see 2 entries available here. Clear? So we have seen git stash save command, and then we have seen git stash list command, and we have something called git stash apply, git stash drop. Apart from that, there is something called git stash pop and git stash clean or clear. And like this, we can able to point out something on a specific time. So what does git stash pop means? The git stash pop also is the same as like your apply command. If I say something like git stash pop, it will reapply changes from stash list to your staging area. But the point is, it will also remove that entry from the stash list. See, test, apply changes back and also delete the reference. If I say stash list, you won't find it. So the difference between apply and pop means so apply is just to apply the changes back to staging area. It is just to apply changes back to staging area. But the changes remains in stash list. Instead of apply, if your intention is to apply changes back and also remove changes, it means you can simply say pop command. This will apply the changes back to staging area as well as remove that entry from stash list. Understood difference now? Guys, do you understand the difference?
Yes. And we do have this stashing list. Those are to the branch specific, right? If we have in feature one branch, we have some files and we apply the stash command. So, you know, we have those listing in the feature ones. Now, let's say if we create the new branch feature two from feature one, and from feature two, can we be able to access the stashing list or not?
No.
Okay. So it's branch specific.
Yes. So now in this case, if you want to move to branch, the scenario what I was saying is from the stash entry, you can able to copy to your branch also. That's possible. So I'll just show you that in some time. So now the difference between apply and pop is this is what it is. If you just want to apply changes back to your staging area, you can use apply, or if you want to delete that entry from stash list also means you can use pop. Use pop command. So now we have something called drop. Drop was used to drop the entry. Stash list. Okay, it is used to drop the latest entry from the stash list. That means assume that you just got the change back. And if you want, you can able to remove that entry from the stash list. You can use drop command. Okay, so usually in real time environment, what we do means we use pop command because we just bring it back to staging area. Also, we'll just delete it from the stash list. Similarly, there is something called what do you call that? Your git status. I think I just bought something back, right? Let me commit this for now. Git commit -m created f2.txt. Okay, I'm okay with the changes now. So what I can do here, I can simply go ahead and drop everything. Let's say git stash clear. See here, the clear option, it will delete all the entries from the stash list. Assume that you have 5 entries in stash list. You don't want all those entries back. You can simply clear it. It's a permanent deletion. Okay, so that's what the difference between git drop and git stash clear. So git drop will drop the latest entry and git stash clear will clear all the entries from stash list. That makes a difference. And one more important point here, like when we talk about the stashing, let me add a few changes here. Echo record one g1.text and then git add. Now I'm going to stash it. Git stash. What is it? Git add dot. So git stash save created g1.text. I can say like this. Similarly, I can add one more entry, g2.text, and git add. And I want to stash this entry. Similarly, I can have one more entry. Right? And I can simply stash this. See, this save command is optional. Okay, the save parameter is optional. Even without this also, you can simply give it git stash. It will create an entry. Now, if we say git stash list, you should be able to see this is my latest entry which I did. This is meant for my g3.text file. If you're not using this save command or save option while stashing, it will assign the default message. It depends upon last commit message, it creates the stash entry. In order to uniquely identify changes, we use the save command and give our own message. Because just by looking at the list, I won't understand for what purpose I stashed it. If I say stash entry 1, you can able to see it is meant for g2.text. And here this is meant for g1.text. So this is how we can able to figure out the changes by using the save message. Otherwise, it will keep on updating with the last committed message. So this was the last commit message, right? So this commit message, based upon this commit message only, it creates a stash entry. But that's not a point here. I was talking about the apply command and drop command, right? If you simply say apply a drop, it will try to apply the changes back to staging area or drop the changes from the stash list. So here, what is the significance of these entries means we can able to use these entries to uniquely identify the content. Let's say git stash drop. If I do this, what will happen?
It will drop the latest entry from the stash
zero.
list.
This entry will be removed, right?
Yeah.
But if I want to remove any of this previous one, I can use this ID here. Like this. See, that has been removed. G1 entry has been removed from that stash list. That is what significance of this ID. Similarly, if I simply say git stash apply, what will happen? It will try to apply the latest changes. That is, the zeroth entry will be added back to my staging area, correct? But if you're interested in this particular item means, you can use this ID here. So it gets restored. You see? So that's what is significance of your stash entry. Any question? Any question here? So we can use these options like git drop using the stash. Like this IDs also it's possible. Just for reference. Right. So apart from this, like for example, consider I'm on this particular branch. I have just these many files created. And if I say git stash, I have this list stash list. I have two entries in my stash list. One is for my F2 changes and G2 changes. So if I don't want all these things, I can simply say clear. Git stash clear. It cleans up everything. Easy. Guys, are you clear with this or not? So that is about stashing. Okay, so once it is stashed, then you can able to move it to any other branches and start working on it. And once you're back to this branch, you can able to continue with your work. Easy. So that's it. That's all about your Git actually. So whenever we talk about Git repository or Git module, so you should know what are the various version control systems available and what is Git and how to work on the Git file workflow. And then you should know about all the miscellaneous commands like creating repositories, adding, commit, especially that reset and revert. Reset and revert are two important scenarios you should understand. And then very important thing is Git branching strategies. Right? And then merging and handling merge conflicts. Importance of rebase, squash, and then we discussed about stash, and then handling remote repositories. Right, so these are the topics you need to be focused on Git module. This is what we do in real-time environment also, nothing else. Any question? Are we good with this module, guys?
Yes. Can you please recall this the difference between Git reset and Git revolt?
So in last session you were there, right?
No, I was not there.
Did you get chance to go through recordings?
No, I did not go through yet. So that's what.
So I recommend please go through recordings because there I have given a detailed explanation about all those things.
Okay.
So on a high level, if you want to understand, both git reset and revert are used to undo the changes. If I made any commits to the repository and if I want to cancel that changes, I can use either git reset or git revert.
Okay.
So git reset comes with three different options like git reset soft, mixed or hard option. And out of that, git reset hard is considered as a permanent removal of the data, starting from the local repository as well as in the working directory. Everything be removed permanently. And git revert also going to do the same thing. Okay, your git revert is something similar to git reset. It is also going to do a permanent removal, but only difference between git revert and reset is the git reset will not maintain any commit history. It just updates the commit history as well, but the git revert will have the commit history.
Okay.
So once you have the commit history in place, at any point of time, you can able to revisit and get back the data. So ultimately, whenever we're talking about the shared repositories, we always recommend to use git revert instead of reset. Got it? Git reset is not recommended in shared repositories.
Yeah. Okay.
So just to know, go to the recordings. I just clearly explained you with some demo also. Like each and every scenario, just explained it with some demo. Just have a glance. Still, if you're unable to understand, let me know. I can explain it again.
Sure. Yeah. Thanks.
Right. So if you all done good with this, let me take these entries for you. So today we started from branch creation, right? And from here I started. This is just for your reference. Okay, tomorrow, if you want to have a quick reference of these commands, you can take it from this notes also. Right. So that's all about your Git module. So next we'll be focusing on Jenkins module. Jenkins module. So shall we proceed? Before that, are we comfortable in this? Please update your. I just opened the poll here for your feedback. Let me know. Just try to update the feedback, please. And definitely this requires a lot of practice. I just clearly given you the instructions along with the commands, execution, everything. It's available in the list. So please practice it before you know get into another module. Guys, hope all are available online, no? I just opened the poll. Please try to fill that one.
It's done from my end.
Yeah, sure. Thank you. All right. So are you guys comfortable with this timing? The timing is 9:30, right? 9:30 to 1:30. Hmm? Shall we continue? I want to have some quick break.
Let's have some break.
Yes.
Okay. How much time?
Yeah, it's enough 10 minutes.
Yeah. Go ahead, please. So shall we continue?
Yes.
All right. So the next module is about the Jenkins module, where we're going to talk about the build orchestration. All are there, right? You can see some of them disconnected, not sure.
Voice is not louder. Hello.
I can see some of them disconnected, not sure whether they'll be joining back. Like, okay, anyway, let's continue. All right. So in our last module, right, like we discussed about the Git, which is used for version controlling the source code. So whenever we talk about the continuous development, it is a stage where the developers will do their continuous coding, and they will do some sort of build and deployment in a higher environment once development is completed. So if you recollect our last day session, we were talking about the importance of DevOps along with the tool stack, right? So in this continuous development stage, in this very first continuous development stage, developers will create the source code, and once the source code is ready, they'll be merging the changes into the source code repository. That's what the DevOps approach we would recommend here. So once the source code is ready, they'll be publishing it to the source code repository like GitHub. Once it is merged into the source code repository, then using this DevOps automation, we are going to perform the automated build, perform automated unit testing, code promotions, and notifications to other teams for further implementation, right? So how we can able to automate these activities? Assume that the code is ready and it is available in source code repository. Now we are going to pick up the code and perform automated build, create the artifacts, and then perform automated unit testing. So to perform all these activities, we need a build orchestration tool called Jenkins. Remember, that is what I was talking about in the last session, right? During introduction to DevOps. So Jenkins is one of the build orchestration tool that helps to automatically build the application, perform the automated unit testing, perform the code promotion to higher environments, and it also takes care of the automated deployments even to the production environment. So as far as Jenkins is concerned, Jenkins is a build orchestration tool. Okay, so we are going to learn about the fundamentals of Jenkins here. So as far as Jenkins is concerned, here you need to understand the architecture first. That is Jenkins. So basically Jenkins follows master and slave architecture. Okay. So Jenkins uses master slave architecture. So what is the purpose of Jenkins master means? Jenkins master is a VM where we install Jenkins, and in this we'll be creating some jobs. Okay, this is what the main objective of Jenkins master. And the slave nodes, this is also a VM which is used to perform the actual builds. So I was talking about these activities, right? Like the build activity, creating artifacts and all. So that will be done exactly in the slave machine. So like this, as per the need, we can able to have a number of slave machines connected to your Jenkins master. So what is the need for all these slave machine means? It can be used for your build activities. Like consider in my at my enterprise level, I have different types of application teams. Like I have a team for developing the Java applications or .NET applications or Python, Node.js, Angular. So each and every team will be using their own build tools. Correct? Hope you are aware of it, right? The build activity means, what is a build basically? Application build means? What do you mean by application build?
Compiling code.
Yeah. Is a process of compiling the source code and creating the artifacts. Artifacts means your binaries. It can be the WAR file or jar files kind of thing. Okay. So let's say if I want to work in my Java application means I'll be using my build tools related to my Java application, and that tool will be installed in slave machine 1. So it means I'll be having dedicated slave machines for each and every type of applications, like for slave 1 for Java application, slave 2 for Python application, like this. So that your Jenkins master can able to schedule the load to the corresponding slave machine. So ultimately the slave machines are something used for distributing the workload, like that also you can say. Why? Because even the master node is capable to perform all these builds using master. Without the slave node also, you can able to use simply master node to perform all sort of builds. But in real-time environment, whenever the types of applications very huge, if you want to integrate more than one tool stack, it is not recommended to dump all the tools in the same machine. So depends upon requirement, you can able to create a number of slaves and add it to that one. So that is what the basic purpose of going with Jenkins master slave architecture. All right. So now, what is the role of DevOps team here? So if you consider Jenkins can be used by the developers, development team, as well as DevOps team. So if you are talking on development perspective, so these developers are just the consumers. Okay, we never consider developers as the owner of Jenkins. They're just going to consume, they're just going to use the jobs, that's all. They're not the owner of the Jenkins. So they no need to be no master in Jenkins and all. All that they should know is what is Jenkins, how to use Jenkins jobs to trigger and check the console output, that's all. So they'll be having just a read access to their own jobs. That's all they can do. But apart from that, if you're talking about Jenkins on DevOps perspective, here the DevOps team, okay, DevOps team own Jenkins. That means they are the owners of Jenkins servers. It can be a master or slave, whatever it is, they are going to own. So they are going to administrate. Okay. And they are going to provision this Jenkins jobs to developers. So ultimately, if you are part of DevOps team means you will be responsible to managing the end-to-end DevOps Jenkins activities. So as a DevOps engineer, what will be your roles and responsibilities? That's what we need to understand first of all. If you are from development background, I no need to talk about all these things. Simply, I can show some jobs and I'll show you how to execute a job and check the status. That's all. But if you are from DevOps background, means you should understand your roles and responsibilities first of all. So as a DevOps engineer, you will be responsible from the scratch, starting from the installation and configuration of Jenkins server. And then we have something called plugins management will be done. Plugins are nothing but some extensions to your Jenkins. Some additional features or capabilities that has to be managed using plugins. And then we have something called user management. That means if any one of a developer wants to use Jenkins, means you'll be giving access to them. And then something called credential management. Something called tools management. Okay, and Jenkins system management. Okay, Jenkins tools management, Jenkins system management, and credential management. And, I was talking about the Jenkins master slave architecture, right? Node configuration and management. Okay, Jenkins master and slave node configuration. And then you will be responsible for managing your Jenkins CI/CD automated jobs or pipeline or project creation. And you'll be taking care of onboarding application teams to Jenkins. And then you'll be responsible for managing or upgrade. Like you can say like upgrade managing upgrades. Okay, and backup and recovery.
This upgrades means Jenkins upgrades.
It can be a Jenkins upgrades or it can be the plugins upgrade, whatever it is. Today you install Jenkins and down the line after 6 months, if you want to upgrade, means that is also comes under this category. So these are the various roles and responsibilities of any DevOps engineer when it comes to Jenkins. And Jenkins is an open source build orchestration tool. Okay, you can say like open source build orchestration tool. So apart from Jenkins, what are the other tools available in market? Means like we have, you can compare Jenkins with Jenkins is very popular. And apart from Jenkins, we have something called Bamboo. And you can consider your Azure pipelines, AWS code pipelines. We have something called GitLab CI. Like this, there are various build orchestration tools available in market. Okay, every tool has its own capabilities. And these things are considered as a managed services. And Jenkins is something called as the open source build orchestration tool. All right, 1 minute. Yeah. Is that clear, guys? Any questions on this? Any question here?
No, I am not.
Okay. So please make a note of all these things, okay? Like even tomorrow during your interview or in your resume also, you can able to add all these things as the roles and responsibilities. Like when it comes to Jenkins management, in any DevOps team, we'll be having at least 2 resources dedicated for Jenkins. Okay, just a minute, just hold on.
Sai, if you're speaking, we are not able to hear you.
All right, guys, am I audible now? Hello?
Yes. Yes. Now it is.
Okay. Yeah, so yeah, that's what I was just talking about your resume, right? Like tomorrow, if you want to update your profile based upon your DevOps, you can able to manage it, okay? At least for 2 places. This training also, the topics, whatever I'm going to cover, with this knowledge, you can able to highlight yourself as 1 to 2 years of experience in Jenkins. That much you're going to learn from this. All right. So let's say,
And sorry, can we get some like real time scenarios experiment?
yeah, we'll talk about it.
At
Okay.
yeah, okay.
We'll talk about it. While we progressing itself, I'll show you what are things we do in a real-time environment, how we manage these servers and all.
Okay.
That's what I'm telling you now. So for 1 to 2 years of experience resource, what are things needed? You'll be learning here.
Okay.
Okay. So first thing is the installation and configuration of Jenkins server. So in order to do this, we are going to rely on our AWS platform. So hope you all have a AWS account, right? Free tier account.
Yep.
On day one of our session, I think we discussed about it,
Yes, we have account.
right? So somewhere I was mentioning that, right? Yeah, this is what the prerequisites. So please ensure that you create AWS account, and it should be a free tier account. Okay, like these are things we'll be considering here. Let me reiterate it. So use this link. People who have not created account, let me put this link in chat window. So you can able to create a free tier account using these parameters, like your valid email ID, mobile number, and the credit card or debit card. And account will get activated within 30 minutes. And once it is available, we are going to create some virtual machines in AWS platform. You can able to create some Ubuntu machine, and through which you can able to create some servers and start working on it. So for our case, for the installation and configuration, create virtual machines. So I'm going to launch 2 VMs. Like one is for Jenkins master and another thing for Jenkins slave node. So here using Jenkins master, I can able to create and manage the Jenkins jobs, and this slave node, it is used to build activity. So this slave node is also called as a build server, where I can install some build tools like Maven, and we can able to perform our application build and create artifacts. So this is what the plan. And once the VMs are created, in order to access a VM from your local machine, you'll be using your SS client like MobaXterm. You guys install MobaXterm by any chance?
Yes.
I have.
Yeah, it's installed.
Okay, I pinged you the link. So if you get in the link, you can quickly download and install it. Just go with the installer edition. Go to the installer edition and install MobaXterm there, through which you can connect to your Jenkins machines. Right. So any questions or issues in doing this activity? Okay, don't worry. I'll just give you step-by-step instructions how to launch the instance and how to install Jenkins. Everything we'll see one by one. Not sure if we continue by now, it will, I don't think we can able to cover it up in another 10-15 minutes. Anyways, I'll try to show you the interface first. So let me log into my AWS console. So people who are using this for the very first time, when you log into AWS console, this is how your user dashboard or console dashboard would be like. Console home, which will give you the list of all the services that you're using very frequently. And apart from that, on top right corner, you can see the account name. You can get to the account settings. And also you can see there is something called region called Mumbai. So this option will get you the list of regions that you enable to use for creating the virtual machines. So in AWS platform, right? In AWS platform, we have something called AWS regions. So regions are nothing but a geography locations, okay, which is composed of AWS availability zones, or it is also called as what you call that? No, data centers. So data centers means where you have your actual servers, the physical servers are located. So if you look into the console here, you can able to see there are a huge list of regions available. And it is always recommended to choose the region that is nearest to your current location. So let's say I'm connecting from India. So in India, in Mumbai region, I can able to access the AWS data centers. Similarly, throughout this, which is your nearest location, based upon just choose the region. And ensure that whenever you create any virtual machine, the virtual machines are getting created in this particular region. That's very important. Understood? Any question here? Guys, do you have any question?
No.
Okay, so regions are nothing but a collection of your availability zones, and within the available zone, you can able to see some list of services. You can able to avail it. And once you choose your AWS region, and from that region, you can able to get into your services. Like for example, if you look into my screen here, so consider I'm choosing Mumbai region. So from Mumbai region, if you want to create any resource, it's very simple. Just on top right corner, you can see there is an option to select the resources or services. So if you click on the service button, you can able to see there is a huge list of services provided by AWS. Like starting from analytics service, application integration, AWS cloud cost management, business applications, and compute service. So we are interested in compute service. Under compute, we are going to use EC2 service. Okay, under compute, we have something called EC2 service. And from here only, we are going to launch some instances. We are going to launch Ubuntu machine, and we'll see how to install Jenkins over there. And for the installation of Jenkins, you can able to follow this reference material. So this page, you put this in chat window as well. See the links, whatever I'm sharing with you people, try to bookmark it, okay? So that it will be easy for your future reference. So this is a page from where you can able to understand the installation procedures. So Jenkins can be installed in any platform like Linux, Mac, Windows, even in your containers, everything is possible. So we are going to install Jenkins in the Linux machines. So Linux also, which distribution you're going to use, whether it's Ubuntu, Fedora, or RHEL, you can able to choose. Based upon distribution, we have to fulfill the prerequisites, and then we'll be installing Jenkins over there. So in tomorrow's session, I'll show you how to launch a Ubuntu machine in your AWS platform. And with that Ubuntu machine, we'll see how to install Jenkins and start Jenkins service. Is that fine? Any question?
No.
Okay, so I'll just stop with this for now. Just to have all these things as a reference. And in tomorrow's session, tomorrow it will be completely a practical thing. Okay, once you log in tomorrow, 9:30, right? So we'll be showing a complete demo starting from the server creation and installation and management of all your Jenkins activities. All right. So for the next 10 minutes, if you have any questions related to previous module or in Jenkins, just let me know.
So please update this file in
Yeah, this will be updated on your documents. Like
GitHub, right?
repository. Yeah. So this is
Yeah.
a repository, right?
Yeah.
So on daily basis, right, it will get updated. So let me update the same level. So in Git itself, I can edit this file. One second. So this is something related to Git first. So let me put it here. Right. So now that we have updated, I updated the Git folder with this Git module. Similarly, I'll be creating another folder for Jenkins. So here you'll be getting a complete list here. Okay, Jenkins introduction is available here, and you can take it further.
Yes. Thank you.
Yeah, so the class recordings, whatever we have, right, the on the recordings, it will be available to you on Monday. They will consolidate your Saturdays and Sunday session, and the recordings will be available on Monday. Right.
Okay, sir.
And one more important thing, next week, right? Next Saturday, there might be some changes in the timing. Maybe we'll start at 10 o'clock. 10 to 2 will be the timing. Okay, might be. I'll confirm this by tomorrow. It's fine, right? 10 o'clock we can start session, right?
Yes, I'm okay with that.
Okay, so
On both Saturday, Sunday.
yeah, Saturday, Sunday, 10 a.m. to 2 p.m. I'll confirm this by tomorrow. Correct. But tomorrow time will be 9:30. That's for sure. Okay, tomorrow there's no changes. But from next week, that is from 14th, session might start at 10 a.m.
Is it just next week or subsequent sessions?
From next week.
Okay.
Okay, just 30 minutes difference would be there. Hope it's fine, right? For all.
Yeah, it's fine.
So in between, I'll be giving you a break also, like 10 minutes break you can have. That's not an issue, but we'll start at 10 a.m. to 2 p.m. Correct? Fine. So any other questions related to Jenkins? Let me know, please. Jenkins or any.
Do we have to subscribe your GitHub account as our DevOps tool for accessing those files?
No, I sent you the link, right? Let me put this link in chat window again. So this is a source code repository where you can get your course notes actually. Okay. So if you want to copy to your account, it is pointing to my account here, right? So if you want to copy to your account, you can click on this fork button. Click on fork and create a fork to your account. Or you can directly use this. No problem.
Do we have to keep the same name, right, for the repository, or it's okay?
Just click on create fork and
Okay.
leave all the parameters default and create again. Click on create button.
Okay.
You create. That's it.
All right.
Right. So yeah. Are we good for today? Any other questions? Hope you all able to understand my workflow, right? My face is okay, right? Or I'm going fast, or what do you feel? Everyone able to understand my flow?
Absolutely.
Yes, I'm fine.
Yes.
Yes, sir.
Or anything, just let me know. We can plan it accordingly. All right. Yeah, no problem. If you don't have any question, you can log off here. I don't have any problem. But tomorrow 9:30 we'll start the session. Please be on time. Tomorrow at 9:30. All right.
Okay.
Hope no
Yeah,
confusion.
yeah. Thank you.
Sure.
Thank you. Bye.
Yeah.
Thank you all.
Thank you. Yeah, people who are on call, do you have any question? Like Vinay, Sahib, Adira. Yeah, I'm waiting for your questions. If you have anything, just let me know, please. Yeah, hello. Appa Sahib, you're there. What's the question? All right, thank you.